Hello! In previous videos, I had taken a look at how to find trig function of any angle when they were in degrees. Then I talked about how we could use radians to measure angles. And now we're going to look at how to find trig functions using radians. Now, it's really the same as with degrees. You'll see that here in just a moment. So let's go ahead and start. The first one is sine of pi. In this example, we're going to think about, okay, where is pi? So if I look on my circle, if this is 0, pi radians is going to be over here. And then we need to find sine. Sine is what in terms of x, y, and r? Well, it's y over r. If my radius is just 1, then r is 1 as well. And in fact, we're going to need to think about that. What is the radius? We could make it anything we want. For simplicity's sake, let's just make it r equals 1. Then what is the coordinates here? What's the x and the y coordinates? Because that's what we're going to need to find the function. So if you think about my x coordinate here, I go to the left 0. Sorry, I go to the left -1 and I go up 0. And so we see my y coordinate is 0, my radius is 1, so the sine of pi is just 0. And sometimes this throws students off when they're making their angle and they get a line, they think, oh, there's no triangle, but remember, we're not interested in triangles, we're interested in x and y coordinates. And so that is the sine of pi. I apologize for my numbering here. I think there was a reason for it at one point, but I've forgotten it now. So cotangent of 7 pi over 6. I think of cotangent, and remember, it's the reciprocal of tangent. I know that tangent is y over x, so I know cotangent is x over y. You might remember it in a different way, and that's fine. But regardless, we really need to think about what cotangent is in terms of x and y. Encourage you really to pause it at this point and try to answer it on your own. Alright, so I'm going to draw my circle. I know that 0 is over here, 7 pi over 6. Now, I'm thinking 7 pi over 6, that's a little bit more than 6 pi over 6, which is pi. So I know 6 pi over 6 is here. 7 pi over 6 is going to be 1 pi over 6. More than that, pi over 6 is 30 degrees. So I'm going to draw 7 pi over 6 here. I've got a reference angle of 30 degrees, or pi over 6. And so now I need to think of my x and my y coordinate here. So I see that my y coordinate is this distance. I also see it's negative. My x coordinate is this distance, and I also see that that is negative. So 30, 60, 90 triangle, I'm remembering it's as easy as 1, 2, square root of 3. 1 is the shortest side, it's opposite the 30-degree angle. 2 is the hypotenuse, and square root of 3 is the middle side, or the long leg. I mentioned it earlier, but make sure to include your negative signs here on your x and your y axis. Or, sorry, on your x and y values, coordinates. So if you take a look now, we're basically finished. Cotangent, we've already talked through, is x over y. So my x coordinate is negative square root of 3 over negative 1. And if I take a negative divided by a negative, I get a positive. And dividing by 1, we just get the square root of 3. I am going to do a few more practice problems like this in future videos. So this is a really key idea, and understanding this, being able to draw the angle, create your little triangle, think about the x and y coordinates. That's really important. So make sure, if you need to, you go back and watch that part of the video. The last one here, secant of pi over 2. You could take a look yourself. Go ahead and pause the video if you're comfortable. Secant, I know I'm going to have to find pi over 2, so maybe I'll just go ahead and graph that. Hopefully you're comfortable with, or at least getting comfortable with radians. We've got 0 here. If you remember, pi is 180. Pi over 2 is half of that, or 90 degrees. Okay. And again, some students at this point want to draw a triangle here. But remember, we're not interested in triangles. We're interested in x and y coordinates. And so the key is really to think about what is your x and your y coordinate. In this case, depends on what our radius is. In the first example here I did with the radius of 1. Maybe I'll do a radius of a different value here, just to show you it doesn't matter. Let's pretend for a second our radius is 5. If our radius is 5, then this is up 5. And so my coordinates then, my x coordinate, I'm going left and right 0. But I'm going up 5. So you can see my x coordinate is 0, my y coordinate is 5, my radius is 5. Secant. Do you remember secant's the reciprocal of what? And maybe you just know the definition, that's fine. It helps me to think of reciprocal of cosine. I know cosine is x over r, so I know the secant is going to be r over x. We already said that r is 5. We found the x coordinate to be 0. So what's 5 divided by 0? Hopefully you said undefined. It is undefined. And so that's our final answer. So what if we would have chosen a different value for r? Instead of 5, let's choose 1. We're working on the unit circle. Well, if I'm using 1, then, oops, don't want to do that. Gonna have to be a little creative here. Ooh, not that big. Okay, so I want to get rid of these because I want you to see that it's no longer 5 up there. It's only 1, right? So this distance to this distance is just 1 now, because that's our new radius. So my coordinate then, I'm going to the right 0, but I'm going up 1. And so now, how does that change up here? You'll see instead of 5, we get 1 divided by 0, which is still undefined. And so whenever we're working with trig functions of radians, the key is just to find the angle wherever that's at, and then find the x and y coordinates. And maybe I should mark that on this one. I relied on my triangle, but I'm really using the x and y coordinates here. In this case, what is my x value? It's negative square root of 3. My y value is negative 1. And my radius in this case is 2. And so even though I kind of used my triangle here, I mentioned x and y. These are really the x and y values. Here again, no triangle, but we look at the x and y values. And then just a matter of knowing our definitions. So make sure to practice this. There's an extra practice maze for this, so you can look at that link. You can also, there is a worksheet that has you practice this. That's a homework assignment.